everybody. We've moved on to welding this down tube into place. We talked about how to miter it. I wanted to show you what it looks like fixtured before I go on to the major welding. So this is sort of my makeshift fixture here. I don't use a full bicycle frame fixture. I can actually convert this to the point where it will fixture the entire bicycle, but due to my space constraints and the fact that I'm not a professional and don't need speed, this works for me. So we've got the bottom bracket fixtured in here. This ball is on a screw. I don't think I can get it off right now. Yeah, there. Big screw that goes through this piece here, so you screw that down. And then you have a precision flat here and a ball that acts kind of like a cone to center this. It's very, very firm once it's in place. Also, that closes both ends of this bottom bracket, which are important, and we'll talk about why that is in a minute. And then here at the other end, I just have a little aluminum V-block. Maybe you can see that there. And then I've got a big clamp. And I went through a lot of effort to this precision flat over here. This can move up and down. So I went through a lot of effort to make sure, a lot of measurements to make sure that the center of this tube and the center of the bottom bracket are parallel and fixtured that way. That's our main goal with this fixturing. And there's a lot of things going on here. You can see I've put aluminum foil with a hose clamp around it. That's just to close off this end of this tube. And then on this end, I've got this. What is this? This is a copper tube with a plastic tube fitted on the end here, just barbarian style. And then I've closed this up with a Kevlar glove that I've jammed in there. And this hose goes all the way over here to our argon tank. So this is our pure argon. And you'll notice I have two outputs here. This one goes to the welding machine. And this one we can control separately. And the reason we do that is when you're welding steel, it becomes liquid. When steel, iron, most metals, when they're liquid, they can react very violently with oxygen. It's not a dangerous reaction, but it does greatly weaken the material. So one of the goals in welding typically is to protect your material from oxygen while you're welding. In the kind of welding I'm doing, that is done with argon gas. So the argon gas is a dense, noble gas, and it's much denser than air. And when you flood an area with argon, it will displace the air and therefore all the oxygen out of the way. So our internal hose of argon is mounted internally to our frame, and we close off as many ends as we can, and then we fill the interior with argon, and that pushes oxygen out. And when material is as thin as this bicycle steel, and I've been talking about how thin it is, that's what I'm talking about. It is very, very thin. Frequently it's like 0.8 millimeters thereabouts. Very easy to burn holes through it. If you look in there, you can see maybe kind of what it looks like when you don't have good argon coverage. So all of this effort is just to provide oxygen on the argon on the inside, displace the oxygen, because this material is so thin that it'll get to that point of reactivity. It'll reach that temperature where it will react with oxygen even while you're welding on the other side. So you've got to do it, and it's called back purging. So all of this, filling it with argon, that's called back purging. It consumes a lot of argon. Argon's not cheap. This is probably, for me, this is the most anxiety-inducing part of the entire process, because every second that I'm repositioning myself or having to fix some little thing or mess with my helmet, I'm spewing argon into this frame. It'd be nice if there's a more elegant way to do it, but for the home operator, that's about the limit. And even for the pros, that's how they do it typically. They might have a little slicker setup with more hose fittings and tighter connections and stuff, but it's the same basic idea. So if you're not familiar with TIG welding, it's a type of welding you don't see very often unless you happen to be in an industry where it gets used. And so a lot of people have never seen it. The big difference with TIG welding compared to most other forms is you have this torch which provides your heat input, and it also provides your argon shield. So argon from our tank runs through this hose. There's a hose in here and our electrical connections in here. And the argon comes out of this nozzle. And so when you're pointing it at something, you're flooding that area with argon at a steady rate. And the idea being you push all of the oxygen away from the point of your weld. And then you have this very, very small, sharp piece of tungsten. I have to grind these down to make this point. And that tungsten is your electrode. So we have our ground clamp, which you can attach to your table or to your object itself. And then you have your tungsten, which is your electrode. And when you get close enough and activate the welder, an electrical arc jumps from the tungsten to the surface of the material. You have to maintain a really, really small but consistent distance between the tungsten and the surface, something like that, to maintain your circuit. So you have like essentially a little lightning bolt jumping from this tungsten to the material, and that generates a tremendous amount of heat. The ultraviolet that comes off of this is actually as intense or more intense than our sun. All that does is melt the metal. If you don't provide more metal to fill in any crevices or any gap in your joint, you'll actually just melt it and it'll move away from the joint and do the opposite of what you want. So we also have what is called filler rod. This is a filler rod. There's lots and lots of different alloys of these. This is a really, really high quality one. It's called TIG Mold 880T. It's specifically for ultra high strength connections in steel and fine steel structures like this. Why go through all this trouble to TIG weld at all? And so TIG welding lends itself really, really well to high precision, high strength, high purity results. So the back purging, the TIG weld providing argon over your weld, all of that ensures you get the highest strength result you can possibly get. In a perfect world, you would weld completely in the fixture, finish all the welding, but the way my fixturing is, it's just impossible to get access to some of the areas. You just can't effectively weld there. So what I do is I do a sequence of welds that I know aren't going to pull the frame out of alignment. I mean, all welds will pull the structure out of alignment a little bit, but the minimum I can possibly achieve. And that mostly means keeping the welds inside the plane of the frame. So if you put one here, for instance, first, it would have a tendency to contract that corner. So the first welds you want to put in are almost always somewhere in the plane of the frame, like here or like down in here would be good. Maybe a little overheated, but it'll work. Good result. Okay guys, Maureen's going to help me try to get some footage of the actual weld pool. We'll see. I'm not hopeful, but we'll try. So this is the last weld on the main frame here. I'm just doing this one little section here to finish up the head tube. You can see the joint that remains right there. So we'll put on our gloves here. We'll turn on our machine and we'll start our flow of argon. And we're ready to weld.
So can I do my part now?
That's that. Looks pretty good. A little hot, but that's okay. Result. That's a done deal.
Did they get to see my shoe?
Nice.